Okay, good morning to all of you. In this class, we are going to discuss in detail about existence and uniqueness theorem for initial value problems and numericals upon this. Okay, so let's start. Now let us consider a initial value problem, that is a differential equation for which initial value or the so-called boundary condition has been given. So this is the differential equation, that is your dy by dx minus 3x equal to 0. Here y is your dependent variable, x is your independent variable. For this differential equation, the boundary condition or the initial value has been given that y0 equal to 2. That means for x0 equal to 0, this y0 value equal to 2. Okay, that means x equal to 0, y equal to 2, or you can say that for x0 equal to 0, y0 equal to 2. Okay, so if the boundary condition or initial value has been given, then what will the answer? Here dy by dx minus 3x equal to 0 or y dash minus 3x equal to 0 is the given differential equation. So dy by dx minus 3x equal to 0 or dy by dx equal to 3x, or dx taken this side, dy equal to 3x into dx, integrating both the side we can get y. Here this will be 3, integration of x is nothing but x square by 2 and some integrating constant c. Let this is your equation number 1. Here given that y0 equal to 0, that means for x equal to 0, y equal to 0, or you can consider x0 equal to 0, y0 equal to 2. y0 equal to 2. Right. So these are the initial values has been given. So we have to substitute these values in our equation number 1. So y will be 0. Y will be 0 or y0 will be 0 when x value will be, sorry, y value will be 2 when x value will be 0. So this will be 2, this y will be 2 is equal to, if I will be put instead of x will be 0, then this term will be 0 plus c. So that implies c, the constant, will be equal to 2. Therefore the initial value problem has only one solution, that is your y equal to 3 into x square by 2 plus c. By considering the initial values, we found c equal to 2, so hence y equal to 3 by 2 x square plus 2. This is the only solution of the differential equation, this one, right? But an initial value problem may have unique solution. Unique solution means one solution or more than one solution or no solution. So here we considered a example and we found that this is the only one solution of this initial value problem or initial value differential equation. But for a differential equation having initial value may have one solution or unique solution or more than one solution or no solution, right? So this can be confirmed by using existence. This is EXISTE, this is E, yeah? Okay, ENCE, existence theorem and uniqueness theorem. So by using these two theorems we can confirm that for a initial value problem of a particular differential equation has unique solution or more than one solution or no solution. Okay, so first we have to discuss about existence theorem, right? So first of all I am going to say to you that the proof of this theorem not inside your syllabus, only theorem we have to use and we are going to solve some numericals. Okay, so here I am reading that statement of this theorem, that if fxy, if fxy, the function which is the function of both x and y, be continuous at all points in a closed rectangular region, that is R, which is defined as x minus x0 mod less than equal to a and y minus y0 mod less than equal to b, where a and b both are positive. Greater than 0 means positive, and fxy mod less than equal to a value that is your m. Here m is the maximum value of fxy. Then the initial value problem of a differential equation, that is your f dash equal to fxy, where the initial values is this one, y x0 equal to y0, has at least one solution, that for all values of x in the interval x minus x0 mod less than k, where k is equal to minimum of a comma b by m. Many things are there, one by one we are going to be understand. Okay, from initial I am going to be study. Again we have to try to understand each and every line. Okay, right. Here fxy be the continuous at any point in the closed rectangular region, this one. Up to this much first we have to understand. So we have to consider a function which is continuous in this region. So here region is x minus x0 less than equal to a and y minus y0 less than equal to b. This defines a rectangle like this. Okay, so what is the range of x minus x0 less than equal to a, y minus y0 less than equal to b? That we have to first understand, right? So here I am going to represent what is the range of x minus x0 less than equal to a. For that we are going to consider one example, that x minus 2 less than equal to 3. So whenever this type of equation you are going to get, you just consider this is a equation of circle. Okay, where x minus x0 less than a. So here x0 is 2, a is your 3, right? First we have to consider this example. So as it is a circle whose center is at 2 and radius is your 3. So center is at 2, this is your 1, 2, 3, 4, 5, 6 and so on, minus 1, minus 2 and so on. So center is at 2, radius is 3, that means 3 means here 1, 2, 3, that means from 2 it will extend up to 5, and left hand side 1, 2, 3 is the radius, means left hand side from 2 it will extend up to minus 1. So having a is your radius, if I will draw the circle by considering center at x equal to 2, or this is also called as the x0, right? This is also called as x0. If I will compare this one with this one, so here x0 equal to 2. So x0 considered as the center and this one is considered as the radius. This is the circle. Now we are going to consider the values of x which will satisfy this equation, right? First we are going to consider x equal to 5. So 5 minus 2. 5 minus 2 equal to 3. So 3 is less than equal to 3. Right. Now we are going to consider 6. Now consider 6. So 6 minus 2 modulus is equal to 4. 4 is now not equal to less than 3. Not less than equal to 3. 4 is greater than that of the 3. So it could not be less than equal to. Neither equal to nor less than. So we could not consider the point 6. Now you consider another point 5.1 just above the 5. So if I am going to consider 5.1, 5.1 minus 2 will be 3.1. 3.1 not less than equal to 3, right? That means I could not consider the points above 5, right? So towards right hand side the maximum limit is your 5 for this case. For this case x minus 2 less than equal to 3, the maximum limit is your 5. Now we are going to consider this side. First we are going to consider minus 2. Suppose we are going to consider minus 2. So here minus 2, if we are going to consider minus 2, minus 4 mod 4. 4 could not be less than equal to 3. If we are going to consider minus 1, so minus 1 minus 2 is your minus 3 and its mod equal to 3. So 3 will be equal to 3. So minus 1 can be considered, and less than that also consider. Suppose I am going to consider minus 0.5. This is your minus 0.5. So minus 0.5 minus 2. Minus 2.5 and its mod is always less than that of the 3. Likewise, if I am going to consider less than 5, suppose 4.5. So 4.5 minus 2 is your 2.5, less than that of the 3. That means beyond 5, greater than 5 points could not be acceptable, but less than 5 can be acceptable up to minus 1. So beyond minus 1 points not to be acceptable, which will be satisfy this equation, right? So for this equation, the minimum point is your minus 1, maximum equal to 5. That means the range of this one, x minus 2 less than equal to 3, is nothing but minus 1 to 5. Minus 1, x is greater than equal to minus 1, less than that of the 5, right? Okay, so here I am going to just write that minus 1 can be written as minus 3 plus 2. 5 can be written as 3 plus 2. So if I am going to take plus 2 to this side, so it will be minus 3, and this will be x minus 2, this will be plus 3. That means minus 1 to 5. This range also can be written as like this, minus 3, which is less than equal to x minus 2 less than equal to plus 3. That means x plus 2 greater than that of the minus 3, less than that of the plus 3. That means x minus 2 mod has the range is this one, or minus 1 x to 5. So here we can write like this, x minus 2 less than equal to 3, this one can be written as minus 3, which is less than that of the x minus 2, less than that of the plus 3. So here minus 2 can be taken this side, it will be plus 2, also can be taken this side, this will be plus 2, 3 plus 2 5, minus 3 plus 2 minus 1. So in general, x minus 2 mod will be written as this one, right, or this one you can write. So here you can see that this value is nothing but a. If I am going to compare this equation, 3 is nothing but a, x0 is nothing but 2. So here instead of minus 3 we can write minus a. Here 2 can be written as x0, this will be written as a, and this will be written as x0. So likewise in general, if the equation is x minus x0 less than that of the a, can be written as minus a plus x0 less than equal to x less than equal to a plus x0, or if x0 will be taken this side, then this will be minus a to plus a. Okay, I suggest to all of you that whenever you are going to interact this type of equation, to find the range you just draw this circle. I am going to give you another example. Suppose x plus 2 mod is less than equal to 3. Here it is x minus 2 less than equal to 3 has been given. If x plus 2 less than equal to 3, if it is given, then what we have to do? So here this is nothing but x minus 2 less than equal to 3. So here your x0 is minus 2. That means if this is your equation of circle, then the center is at -2 and its radius is 3. So if I am going to draw the circle, this is 1 2 3 4 5 6 -1 -2 -3 -4 -5 -6. So center is at where? -2 1 2. This is -2. This is your x0 and radius is 3. That means 1 2 3 up to this much. This side also 1 2 3. That means -2 -3 -4 up to -5. It will be range. It will move to this much. And here -1 0 1 2 3. This is 1 0 -1. So this will be the center and this will be the so-called circle. Okay. Now we are going to consider the x values which will satisfy this one, right? Now you just consider 2 beyond this one. If I will consider 2, it will be 4 not to be less than 3, right? Now consider -6. Here -6 plus 2 mod will be 4 not to be less than 3. That means the range of this equation will be -5 to 1. That means I am going to write -5 less than equal to x less than equal to 1. Okay, from this circle I found, or in this way also we can found like this, that x plus 2 mod less than 3. So this can be written as -3 less than equal to x plus 2 less than equal to plus 3. So this is -2 plus 2 will be moved this side. This will be -2 -3 -2 less than equal to x, and this will be moved this side 3 -2. That means -5 less than equal to x less than equal to 1. So in this way you can also do, or you can found the range, but I suggest that you just remember this method, which will be always required in different questions. Okay, so here we found if x minus x0 mod less than equal to a has been given, that means range is your what? Minus a x value having the range in between minus a plus x0 to a plus x0. Likewise, if y minus y0 less than equal to b, then the range will be minus b plus y0 less than equal to b less than equal to y less than equal to b plus y0. So here this is the range of y, this is the range of x has been given here, rectangular region, where for the rectangular region. So here if this is the considered as x, this is considered as y, and if this is your x0, so x0 minus a, let this is the point, that is your x0 minus a, x0 plus a, here a0 plus x0 we can write a plus x0, this one. Okay, this point. Likewise, if this is your y0, so y0 minus b will be this point, y0 plus b will be this point. So if I am going to draw the line, this line is represent x equal to minus a plus x0, and this line is nothing but x equal to minus plus a plus x0. See, both a and x0, minus a and x0 are constant. So this is a number. X0 is a number. X0 is a number. So x equal to a plus x0 is represents equation of this line. This is the equation of this line. Likewise, this is the equation of y equal to b plus y0. This is the equation of y equal to b plus y0. If y0 equal to 0, then it will be, if suppose this x0 and y0 both are at origin, so this equation or the line of this equation will be what? X equal to a, because x0 equal to 0. Likewise, this one will be y equal to b, and this will be y equal to minus b. Sorry, this will be minus b plus y0. So if the rectangular region has been given this one, and fxy is the function exist in this region, this theorem, existence theorem, what it is telling, that we have to consider fxy fxy which is continuous. Continuous means at each and every point the value can be identified, the value can be found out. Suppose I am going to say that, suppose this point we are going to consider, at this point suppose fxy it is like this, 1 by x plus x minus 3 is there. This is the function, suppose. So this function could not be defined at x equal to 3, because at x equal to 3 this will be 0, not to be determined. But it is not so. This function, that means at x equal to 3, suppose this is the point belongs to x equal to 3, suppose this is the point belongs to x equal to 3. But here we could not be defined. We could not define here. This is the point where the function is not continuous. So this type of situation is not there. According to this theorem, this function is everywhere continuous, everywhere continuous in this rectangular region, right? And fxy will be, then we are going to find out fxy modulus will be less than equal to a value m. What is this m? M is the maximum value of fxy. Okay, again I am going to read, if fxy be continuous at all points in closed in rectangular region, this is our closed rectangular region. So this is x0 means this is the point minus a plus x0 plus a plus x0, and this is y0 means this is minus b plus y0, and this is plus b plus y0. This is the rectangular region in which fxy at all point, at each and every point it is continuous, and where a and b are positive value, where a and b we are going to consider positive, right? And fxy has some maximum value. Fxy has a maximum value, that is your m. Okay, then the initial value problem means y dash or fxy, for y x0 equal to y0, this is the initial value, has at least one solution, that for all values of x, that means up to this much if we have, that means a function is a continuous in this region and it has a maximum value is m, then its initial value problem, that means this is the initial value problem. In general we can write, for a function we can write this is the differential form and initial value is this one. Then the initial value problem has at least one solution. The theorem is telling that if fxy is continuous in this region and fxy has a maximum value m, then its initial value problem has at least one solution, that for all values of x, but this x has one range. What is that range? In the interval x minus x0 less than k, where k is the minimum of a and b by m. So here this is the a and this is the m, b by m we are going to consider. So both a and b by a, which was the minimum, that we are going to consider x, and this initial value problem has at least one solution for all values of x in the range this one. Suppose we are going to consider this x0 equal to 3. Suppose this is x0 equal to 3 and we found k value is 1. K value we found 1. That means for a given differential equation or initial value problem, for all x values it has at least one solution. It has at least one solution we can get. For what are the values of x? X will be this one, less than, this is the range. What is the range? X minus x0 equal to 3, okay, less than 1. That means this will be minus 1 less than x minus 3 less than 1. So this will be how much? This will be x, if I will take minus 3 this side, it will be 2. So 2 to x to 4. So 2 to 4, in between 2 to 4, for all values of x, in between 2 to 4, what it is told? That at least one solution, that for all values of x in the range of this one. So here, by considering this example, we got that in between 2 to 4, what are the values of x we can get? For those values of x, at least one value of x, we are going to get the solution. That means at least one solution, that for all values of x in the range x minus x0 less than that of the k. So this is all about the existence theorem of initial value problem. So now we are going to go for the numericals by using this existence theorem. So this is the one numerical that we have. A initial value problem is this one: y dash equal to y, y0 equal to 1. That means this is your x0, this is your y0 has been given. The range of x, range of y has been given, corresponding rectangle. Now we have to investigate the existence of the solution. That means for this initial value problem, there is some solution exist or not, that we are going to check first. Okay, so let us do it. So in this question, it has been given that y dash equal to y, y0 equal to 1, and the region is this one. So first of all, we are going to draw this region. Okay, so this is nothing but, it is given that x minus 0 less than equal to 1. Here x mod less than equal to 1, that means x minus 0, I can write x minus 0 less than equal to 1. And here y minus 1 less than equal to 1. Okay, so here for this case, x0 is nothing but 0, y0 is nothing but 1, right? So in this xy plane, this is your x-axis and this is your y-axis. So this is each small division is 1 1 1 1 like this. So this is 1, this is 2 3 4 like this, minus 1 minus 2 minus 3 minus 4 like this. And likewise along y-axis, this is your 1 2 3 like this, minus 1 minus 2 minus 3 like this. So now we are going to go for the solution. Given that y dash equal to y, that means fxy equal to y. Here you can see that y dash will be considered, according to the theorem, y dash will be considered as fxy. So here y dash equal to y, that means fxy equal to y, right? And from the initial value, it is given that y0 equal to 1. That means this value is nothing but x0. That means x0 equal to y0. That means x0 equal to 0 and y0 equal to 1. Here I written clearly. That means for x0 equal to y equal to 1, or you can consider x0 equal to 0. For x0 equal to 0, y0 equal to 1. This is the initial value whatever given. So here the region range separately I have been calculated. You can see mod x less than 1, that means x minus 0 mod less than 1 less than equal to 1. So here 0 is nothing but x0, right? So we can write minus 1, this is nothing but minus 1 less than equal to x minus 0 less than equal to 0. So this will be minus 1 plus 0 will be minus 1, and this is 1 plus 0, like this format I am telling you. Okay, if x minus x0 less than a, so this will be minus a plus x0 to plus a plus x0. So here minus a is your minus 1, minus 1 plus x0 means 0 up to plus a plus x0 means 0. So x range will be minus 1 to plus 1. So minus 1 to plus 1 is the x range. But y range will be how much? It is given that y minus 1 less than equal to 1. That means y0 equal to 1. Right? So this can be written as -1 to +1. -1 less than equal to y minus 1 bracket is there, not mod, bracket less than equal to 1. So here this -1 will be add here and here. So -1 plus 1, here 1 plus 1. That means y range will be 0 to 2. 0 to 2 y range. So here y range is from your 0 to 2. That means from here to here. So x range is -1 to 1. So if I am going to draw a line here, this line will be called as x equal to -1. This line is nothing but x equal to 1. This line is nothing but y equal to 0. And this line is your y equal to 2. And this region is your given rectangular region as per the theorem, this one, right? And here a and b is nothing but this one. This is considered as a and this is considered as b, right? Here I written also clearly maximum value of x is how much? Your 1. Here maximum value of y is your 2. And the rectangle of R which is enclosed by x equal to -1 is the line. This is the line. X equal to 1 is the another line. X equal to 0 line, one line. X equal to -1 is another line. So the rectangle whatever given in the question which is enclosed by these 4 lines as shown in the figure, right? Here maximum of y and x are 2 and 1. For y maximum value is how much? 2, and maximum value of x is 1. So according to the existence theorem, maximum value of fxy is nothing but y mod. See, here it is given that fxy equal to y. So fxy mod is nothing but maximum. Here fxy mod is nothing but m. So we need to find out the m, because to find out the k we need m, right? So here for this case maximum of fxy is nothing but given that y, only y. So y mod we are going to consider. Suppose in the question it is given x plus y, so we have to consider x plus y mod, but as it is given only y, so we are going to consider y mod. But y have the maximum value is 2, so 2 mod is nothing but 2, the value is m, right? Now we have to find out the k. K is nothing but minimum value of a and b by m. A is nothing but 1, this one. This is nothing but 1 a value, this is nothing but b value. You can see that in your theorem, x minus x0 less than equal to a, y minus y0 mod less than equal to b. So here this is a and b. As if I am going to compare this with this one, so this is your a and this is your b. So k, so a equal to 1, b equal to also 1, k will be minimum of 1 and 1 by m. 1 by m means 1 by 2. So if I am going to compare 1 and 1 by 2, which one is the minimum? Minimum is 1 by 2. So k we found 1 by 2. So according to existence theorem, the solution, here we got k value. Okay, so according to existence theorem, if I am going to follow the existence theorem, then we can say that at least one solution exists for all values of x having the range this one, a to b by m. Sorry, x minus 0 which is less than to k. That means here we got k value is 1 by 2. So here we can say according to existence theorem, the solution exists, the solution of this initial value problem. You just write down this one. Solution of this initial value problem, of this means this one, of this initial value problem exists for all x values in the interval what? X minus x0 less than k. So here x0 is how much? Here x0 is 0. You can see here x0 is 0 here. So x minus 0 less than that of the 2. That means what is the range? Range is minus 1 by 2 x plus 1 by 2. In this range, for all values of x, at least one solution has to be exist. Okay, has to be exist. So this is the solution of this numerical. We are going to go for the another numerical, this one. Study the existence of the solution of the initial value problem. Here y dash is given as x square plus y square, y0 equal to 0. So here y0 equal to 0 means x0 is your 0 and this is nothing but y0. Here I written, no problem, you should not be worry about this. Here I written clearly in the note, but here in the question it has been not given any type of rectangular region. In the question not given rectangular region. So in this type of question we have to define our general rectangle. General rectangle is your what? As x0 already given the 0 and y0 already given 0. So we have to define the general rectangle as we know that x minus x0 less than equal to a and y minus y0 less than equal to b. So x0 and y0 is nothing but 0, 0 and 0. So the rectangle region is your x minus x0 less than a, y minus y0 less than equal to b. So here x0 equal to 0, y0 equal to 0. So this is the rectangle region. May it is not given in the question, but you have to define yourself for this type of questions, right? So now we are going to discuss the solution of this question. Here it has been given that y dash equal to x square plus y square. That means fxy equal to x square plus y square. See, according to the theorem, what is the y dash? That is considered as fxy. So here y dash x square plus y square means fxy equal to x square plus y square, given that y0 equal to 0. That means yx0 equal to x0. So you can read as like this: x equal to 0, x equal to 0, y equal to 0, or the so-called x0 0, y0 equal to 0. So x0 0 corresponding y0 also 0. Now as I told that here not given the rectangular region in the question, but we have to define ourselves that this one x minus x0 less than that of a, y minus y0 less than equal to b. This is the general expression of the rectangular region. So in the question it has been given the y0, x0, y0 value. So we have to just substitute x0 is 0, y0 is 0. So this is nothing but the region, range of x, range of y, or the so-called region of rectangular region as shown in this figure. So here you can see x minus 0, that means x mod less than equal to a, y mod less than equal to b. That means this is nothing but minus a to a, x range is minus a to a, y range is minus b to b. So by using these two ranges we can draw the rectangular region. So here minus a to a, x range, y range is minus b to b. So by considering this range, so if this is a minus a, so this line is nothing but x equal to minus a, x equal to minus a, this line is your x equal to a, this line equal x equal to minus b, and this line equation is x equal to b. So this is your region R, rectangular region. Okay, so remember that if in the question not given any type of information regarding region, you have to define like this. So suppose it has been given that y 0 equal to 1. Suppose it has been given, that means x0 equal to 0, y0 equal to 1. So here it will be y minus 1 less than equal to b you have to consider, right? So like that you have to consider the rectangular region. Now we have to find out the maximum value of fxy. For that, here you can see the maximum value of y is b and maximum value of x is a, b a. The maximum values of y and x are b and a, right? So maximum value of fxy, which is nothing but m, will be how much? X square plus y square, because fxy is nothing but x square plus y square. So x square plus y square less than equal to a square plus b square by, or we can say, we can consider instead of x a square, instead of y b square. So if I will be if I am not going to consider mod, then it will be less than or equal to a square plus b square, which is equal to m, right? Now we have to find out the value of k. K is nothing but minimum of a and b by m. So a, b by m, m is nothing but a square plus b square. You just substitute over here, a square plus b square. Now which one is the minimum? A is the minimum or b by a square plus b square is the minimum? How we are going to be find out? Here it is not given that a is greater or b is greater. It is not given like this, but for our convenience we have been considered a is greater and b is smaller, and we drawn the rectangle. But as it is not given a and b value, the rectangle may be like this. Okay, along y axis it will be large, and along x axis it will be small. It can be drawn like this itself. So as it is not given the value of a and b, so the rectangular region can be drawn like this or like this. Okay, whatever I drawn here. So only for that, to finding the minimum value of this between this and this, which value is the minimum or minimum value in between a to b by a square plus b square, what we have to do? Consider. Let now consider f ab is another function which is nothing but b by a square plus b square. Okay, for one value of b, the f ab will give its minimum value. Now we are going to consider for a particular value of b, this f ab gives its minimum value. So minimum value, suppose for particular value b, this value is minimum. That means if I am going to differentiate this one with respect to b, then it will give the value 0, right? So here differentiation of this one with respect to b at a particular b we do not know. Here only for that I put a question mark. B is anything. Okay, b can be anything. So b is a constant, can be anything, will be equal to 0. Now we are going to consider the differentiation of this one, FAB d by db of b by a square plus b square. So here this will be the division rule. You have to apply a square plus b square whole square, and derivative of this one into this one, derivative of this one with respect to b is 1 a square plus b square minus b into derivative of this one with respect to b, this will be 2b. And here you can see after simplification we can get a square minus b square by a square plus b square whole square. Okay, so for a particular value of b, this value is to be 0. B is unknown. Okay, b is unknown, what I told, but for a particular value of b, this value if it is minimum, then derivative with respect to b, it has to be 0. So derivative of this one, we found this one. If I am going to equate equal to 0, then b value will be how much? B value will be a. That means for b equal to a, this value will be minimum. That means b by a square plus b square will be the minimum, if b equal to a. Now we have to put instead of b a. So it will be how much? A by a square plus a square. That means a by 2a square will be 1 by 2a. So now instead of writing b by a square plus b square, I can write this one 1 by 2a. So k value will be minimum of a and 1 by 2a. So by comparing a and 1 by 2a, which one is the minimum? Obviously 1 by 2a is the minimum, right? That means therefore k will be equal to 1 by 2a. The minimum comparing with a and 1 by 2a. 1 by 2a will be the minimum. So k is your 1 by 2a. So according to existence theorem, we can say that the solution exists for all x value in the interval x minus x0 mod less than equal to 1 by 2a. Here it has been written less than or less than equal to. Just wait. In the theorem it is written less than, right? See, some books are written in the theorem x minus x0 less than k, and some books they are written less than equal to k. So you do not change over here. K keep it, whatever written in your theorem, keep it as like this. But at the end of the numerical, may you can write less than equal to 1 by 2a, no problem, or less than equal to 2a. X mod less than 2a you can write, or less than equal to 1 by 2a you can write, no problem at all. Okay, so that is the range, means minus 1 by 2a, less than x less than 1 by 2a. So that means from this problem we concluded that this is a initial value problem. For this initial value problem, for all value of x in the interval this, at least one solution has been exist. Okay, according to existence theorem, the solution exists for all x in interval x mod less than equal to 1 by 2a. You can write less than, only less than 1 by 2a you can write, that is minus 1 by 2a to 1 by 2a. In this range, whatever the x values, among those x values at least one solution has been exist. Okay, so here we have been discussed the theorem, okay, and corresponding to numericals, example 1 and example 2. So here we have to stop our discussion. In our next class we are going to discuss uniqueness theorem and its corresponding numericals. Okay, so thank you so much for watching this video. Thank you.